All right, so for the second part of this problem, we're gonna find what is the x operator, what is the average position of our particle. So we're gonna say that it's equals to the capital psi with the x operator and capital psi. This means that we're gonna have um, the first part, and it's gonna be the complex conjugate of it. So we're gonna have a positive part over here. Uh, yes. Yeah, so this times x, and the second part, which will now be a complex conjugate, so just going to be this part right here, as you can see. Okay, so uh, in order to do this, we have to multiply everything. So the first part we're going to get, well, 1 over 10, because we have 1 over square root 10 two times, and then we have the psi 2 with the psi 2, so we're going to get psi 2 terms of x squared, and then we have this. Oh, you know what? I wrote it not very well because this multiplies the whole part. So this part right here. Okay, and so we have the time part times the time part, which is going to be equals to 1. And so this is equals to 1 over 10, and the uh, this part over here is equals to 1 again. So that's a easy answer for the first part. And then we're going to have our side 2 in the first part, and then side 3 in the second one. And then we're going to have 1 over 10, again, of course, and then side 2 terms of x times side 3 terms of x times 1, of course, because we're multiplying the times part, which is always going to be equals to 1 in that case. At least for now, actually. We have to make a distinction, actually, before I go ahead, because here it matters. Because if we're talking about psi 2, we're talking about the capital psi 2, we're going to have that is equals to psi 2x, and then times e to the power of negative I e 2t over h bar. We're talking about capital psi 3 xt. Then we're going to have psi 3 in terms of x times e to the power of negative I e 3t over h bar. So with this in mind, the first calculations doesn't change, it's still correct. The second calculation is still changes a bit because as I said, we take always 1 over 10, we said. So far so good. And then we have psi 2 in terms of x times psi 3. Oh, psi 3, okay, psi 3 in terms of x times, then we have our first e to the power of negative I e 2t over h, and then times e at the power of, well, sorry, the first one will be a complex conjugate, so it's going to be a positive over here, and then the second one will be negative I e 3 times t over h bar. And then we have, where we're done with the first side 2, the first one, so we're going to have 3 side 3, so, oops, I forgot 3 over here, sorry. And so we're going to have 1 over 10 times, we have 3 side 3 x, and then multiply by side 2. So psi 2x e times, for the first part, we'll have a positive e at the power of I h 3t over h bar times the second one, which will be a negative, so negative I e 2t over h bar. All right. Okay. Oh, we're forgetting that there's an x in every single one of these. So I'm gonna add x over here, x over here, x over here, because it's the momentum, it's the position operator. So this one is the third product, and I'm gonna use the fourth, which is gonna be equals to, let's cancel out the note that's on for this one here. So I'm gonna have 3 side 3, 3 side 3. So 9 over 10 psi 3 in terms of x squared, and then I'm gonna have the 1 after, because we would have e to the power of negative I e3 t over h bar times e to the power of I e3 t over h bar, and this cancel out to become 1. Okay, and we know that this part over here is equals to 1, so my final solution, let me take this over here and bring it farther so you can see it, but it's on the middle. So we're going to have 9 over 10. Okay, so now what do we do this to right here? Well, we can think of this as written a little differently. The first one is going to be equals to 1 over 10 times the bra times the ket of our side 2 in terms of time, x operator, and side 3, the capital. Of course, we're talking always about time. And the second one will be equals to 1 over, I have a 3 in front of each one of these. Yes, so we're going to have a 3 and 3. So we're going to have the psi ket side 3 x ket and bra side 2, which the first one is going to be equals to, of course, 3 over 10, and then actually I'm going to go on a little more space because I want to prove something. So one thing that we know is that if we have, I'm writing in blue because it's a note, y psi n position operator with psi l, this is going to be equals to the integral from, well, in this case from 0 to infinity, from negative infinity to a positive infinity. Now in our case it's going to become from 0 to a because of the condition that we applied at the beginning. And so it's going to be the first sine of n is equals to square root of 2 over a sine of n pi x over a. Okay. And the second L is that is going to be equals to square root of 2 over a sine of L pi x over a. So I can rewrite this inside. I'm going to say, I'll have to actually take this and just make it a little quicker. Duplicate, paste it over here, and say in blue. I'm going to take over this one over here, duplicate it, paste it in blue. And as we said, there is an x in between. So we have to remember this trick over here. So if we retake our part that we have over here, copy and paste over here, we know that this is equals to 3 over 10, and then the integral from 0 to a of the first one, we said, but instead of n, we have 2, so we're going to have square root of 2 over a, and then sine of 2 pi x, 2 pi x over a. Okay, the second one, sorry, x in between, and then second one, which is square root of 2 over a sine of 3 pi x over a dx. Okay, so here we get 3 over 10, and then oops, I forgot to rewrite the time interval because this function that we looked over here, they were not a capital, they were just normal, the little psi. So I'm going to take this part over here, because we're talking about capital psi, and paste it over here. Doesn't really matter because we're not talking about the, it's not going to be integrated in terms of time anyway. And then take out the constant, I'm going to have 2, oops, 2 over a, and then I can rewrite this as e at the power of I e2, actually I t over h bar with e times e2 minus e3. Okay, and then again the integral from 0 to a of sine of 2 pi x over a x and sine of 3 pi x over a dx. So I'm not actually going to do this. I'm just going to use a integral calculator. So I have sine of 3 pi x over a, sine of 3 pi x over a from 0 to a dx. And so it's going to be equals to, this part is the same, we said. It's going to be equals to okay, I forgot to write an x in the recalculate. Okay, it's going to be equals to negative 24a squared over 25 pi squared. And that is for this part over here. Now, one thing that we can look at is that this one over here is going to be very similar to the first one. So I'm going to I'm going to rewrite it in the expanded form, in the integral form, and show you that it's going to be very similar. So it's going to be equals to 3 over 10, the integral of, well, again, square root of 2 over a, sine of 3 pi x over a, x, and then square root of 2 over a, sine of 2 pi x over a dx. And again, the time part, I'm going to copy and paste over here. So I'm going to take out all the constants. It's going to be 3 over 10 times 2 over a, and then the e at the power of, I'm going to write this as I t over h bar times e3 minus e2. Okay, and the integral of, I'm going to rearrange it so you can see what I mean. From 0 to a, of course, we're talking about from 0 to a. Sine of 2 pi x over a, x, sine of 3 pi x over a dx. And if you notice, this integral that we found right here is going to be the exact same thing as this integral right here. So we're going to get similar thing. So the answer over here will be equals to, this part over here remains constant. And then the answer that we got out of the previous one was negative 24a squared over 25 pi squared. So I'm going to simplify something, the a over here, and same thing I'm going to do for the one up here. So for the previous one, I'm going to get that is equals to, let's see, what is it? 3 times 2 times 24, 3 times 2 times 24. So negative 144 over 25, 250 actually. And then it's going to be a the top, pi squared bottom, and then the e with the exponent remains the same. Okay. Then when the app decided to crash, right when we were about to have fun. Okay. There we go. Okay, we're back. So we said it was is equal to negative 144 times a over 250 pi squared. Okay, and same thing over here, negative 144 a over 250 pi squared. So what is the difference between the two of them? Well, this e, the power that I was about to do it before when it crashed. There we go. Oops, I'm gonna. Yeah, just, that's the power, that's not multiplication. Okay, so let's rewrite the whole thing. um, so, okay. I'm gonna start rewriting these two, so the 1/10 x, of course, and the 9/10 x. They actually, I didn't do it, but I should have. That was my mistake. I should have integrated them as well. I guess I'm gonna have to do it now. So this one is equals to the 1/10 over, because here we have an x that I forgot to write, and the one, of course, from the e. So it's equals to this part here, x e. Okay, so 1/10 over the interval from 0 to a of our function psi squared x dx. Yeah, so 1/10 again, and psi squared we said was equals to 1, so x, we're gonna get 1/2 x squared from 0 to a, so we're gonna get 1 over 20 a squared, which seems correct. Okay, and same thing over here. I forgot to write the x over here, indeed. So 9/10 x, but as I said, it's like rewriting this as 9 over 10, and then psi 3 x psi 3, so equals to 9 over 10, the integral from 0 to a, psi 3 squared x dx. Psi 3 squared is equals to 9. That's why we got the 9 in front, actually. So psi 3 is actually equals to 1. I'm sorry, the constant in front is equals to 9. So this part over here is equals to 1. So this part over here is going to be equals to 9 over 10, and then 1/2 x squared from 0 to a. So again, 1 over 20th a squared. Okay, so we're going to get a 1 over 20 a squared plus 1 over 20 a squared, and then minus this part here that we found. Well, I already wrote the minus, so I need to rewrite it again. It will be plus the part, but it's minus to then, and then plus this part here, so minus this. I end up with 2 minus it. Okay. So let me see if I can solve something. Yeah, I can take out an a. That's that a, and then a 10. That's what I get inside now. I get a over 2 plus a over 2, which becomes in a, plus 144. This one cannot be touched because they have two different coefficient atoms. So 144 over 25 pi squared, and then the e remains the same, and then minus 144 over 25 pi squared, and then e, that is again the same. So let me finish rewriting again. I'm gonna get a squared over 10, and then times a minus this. Or the minus, so right this. Okay. And that's not actually the final answer, because what we can do is a squared over 10 times a minus, and then I collect the 144 minus 25 pi squared. Yes, let me check one thing. Yeah, and then this e, the power of it over h, times E2 minus E3. And it will be then plus E3 minus E2. Okay. Or let me just rewrite it a better way so you can understand why I'm doing this. Plus e to the power of it over h bar e3 minus e2. This one is equals to the cosine. So it's going to be equal to the cosine of e3 minus e2 times t over h bar. We got it better. So is there to read? Okay, there we go. I think I forgot to multiply 2 somewhere. I'm sure you can find it somewhere. So was the a squared not an a squared? Oh yeah, it wasn't an a squared in front. I just pulled out an a. I don't know why I said a squared. Okay, yeah. So here I get a over 10 times a minus 144 cosine of e3 minus e2 times e over h bar times t. Sorry, I don't know why I wrote e. T, and then again t over h bar over 25 pi squared. And that's our final answer. It was a little complicated, I'm not gonna lie, just especially long. But I hope it was helpful. Let me know if you have any questions.